Hello everyone. In this video, we are going to look at some image processing and computer vision in CoppeliaSim. If you watched my last video, I showed you some basic processes like you get the image and then you can like flip the image horizontally, vertically. You can do edge detection and so on. So here I'm going to show you a couple of image conversions. One of them is a grayscale, the other one is binarizing the image and then finding the biggest blob. And then on the biggest blob, you want to add a bounding box and a centroid, and you want to show the coordinates for the centroid and the numbers for the bounding box, which involves one corner and width and height on the screen. Okay, I'm going to share this script with you. Under video description, this script here is written in Lua and it's well commented, so you should be able to understand it. Now, let me first run it for you so you get an idea. The parameters that you want to control are here. So this is the threshold for binarizing the image between 0 to 1. This is the minimum blob area below which it's ignored. This is the thickness of the bounding box. This is the half of the crosshair size on the centroid. This is the number of frames to do a process on. So here I'm not going to do process on every single frame on the vision sensor, only every 5 frames. Why? Because it is quite a bit heavy and slows down the whole simulation. Even with 5, I'm going to show you that the robot is going to move very slowly because this processing, especially the part that you do the blobs and everything, that is heavy for the simulation. And then this is to keep track of frames and so on. And here, this one is, if it's true, it shows the binary. If it's false, it shows the grayscale. So right now, let's go ahead and put it on false. Okay, so if you put it on false, all we should see is the grayscale image of the scene. So let's go ahead and run. There we go. You see that the background is only black here. And even if I bring down this sensor, you're going to see some white as well. So here is your robot, and I put the camera up so the only thing it really sees is the robot, not the floor. You can add that, but clearly you see that it's grayscale, and this is slow motion because, again, this is a heavy computation. Now here we are going to put it in the binary mode. So let me show you the binary mode again. So we go back to true and run it here again. So let's start. There we go. You see the red bounding box and the green crosshair. And here you can see the coordinates for the centroid and, as I said, the 4 numbers for the bounding box. So you can keep track of the largest blob here. And the blob is a 4 connected blob. If you need to know more about them, you can look under my playlist Computer Vision Image Processing and check morphological operators to see how this one is working. So, and this is with the threshold of 0.35. So if you use a smaller threshold, probably you get more pixels, but you can get some extra noise as well. And if you get a bigger one, you're going to lose some of these pixels. So here, let me just briefly go over the script. Just tell you which part is which. So here I told you these are the setting parameters. This line here is to get the handle of the vision sensor. This part is doing the cleaning. Okay, so it cleans the centroid signal string that I'll show you, the basically bounding box, and then when it's closed, it cleans up the sensor handle. And now here, these are the ones for running every 5 frames. So this is for speed. Now, this is the main part of the code that handles the centroid and the bounding box, okay? So it's called largest blob props, right? In MATLAB, remember, if you had a binary, it was called region props. So here you pass to it the binary image and you pass to it the size of that image and you give it the min area, and the min area is the minimum area threshold to consider a component. Okay, so this minimum number of pixels that you want for a blob to have, below that you ignore it. Okay, and then this one here is basically going into the binary and gets the largest connected component. Again, it's called for connected. And then once it finds that blob, it is going to give you the centroid and the bounding box. And all the calculations for the centroid and the bounding box are here done, basically using the moments and the scan of the rows and the columns. So here you are literally doing it with loops, as you can see, and with ifs. So because you have a double loop here going over every row and every column in that blob, you are going to get something slow. Okay. And then if it founds the blob, then it is going to give you the X and the Y, and it is going to give you the X, Y, and the size of the bounding box, as I said. Okay, now this is the sensing. So it is going to start handling the sensor, adds to the frame number. If the modulus of the frame number with n, which is 5, is not 0, that means don't do anything. Otherwise, you have to do the processes. Now, here we go ahead and get the grayscale image from the vision sensor. Can you get grayscale directly out of the vision sensor? Yes. Here, this handle 1 means get the image in grayscale. Remember, in previous videos, we did not use this 1, right? We could use a 0 and get the RGB image. Here, we are using 1 means grayscale. And if you use 2, it also gives you the alpha channel, and alpha channel means opacity. So here I'm showing you the options that you can use with the get vision sensor image. So we are directly getting it in grayscale. Now, if we not get an image grayscale, that means the sensor must not be active or there is something wrong with it. Otherwise, we start the binary image as empty, and then we compare each and every one of the pixel intensities against the threshold. If it's bigger than the threshold, we set it to 1. If it's less than that, we set it to 0, okay? And then here we use that function that I showed you earlier, this function here, to get you the blob and the bounding box of the largest blob and the centroid. Here we create strings from this information, and then we are going to show them on the status bar message. Okay. And finally, we are going to overlay the information and show it on the display. What information? Well, if it's grayscale, it's just grayscale. But remember, if it was binary, you have to show a red bounding box and you have to show a green crosshair for the centroid. So you have to basically convert that binary image back into an RGB image and then show it on the display here. So you have to form an RGB image, and here, once you make it, call it the last RGB, you are going to use the command set vision sensor image. You pass that image to it, and that is going to display it on the display window as I showed you. So here we go, right? You can see that, and again, you can change the thickness of this red box, the size of the screen. You can go ahead and change the threshold here. You can make it binary or grayscale. There are other things you can do. If you want to change the color of the bounding box or anything, you can also do that. So look here, you're drawing a green crosshair. And why? Because your RGB is 0 to 550. So if I want to make it yellow, for instance, I can add a red as well as the green, right? So now it should be basically a different color for the bounding box, or sorry, the crosshair. So look, the crosshair is now yellow, as you can see. So feel free to change the color, right? Any way that you like, modify it. I guess actually blue is, in this case, much cleaner than red or green or yellow. So I would rather change it to blue, and The rest of it is good to go. So this to me is more visible than the green is. So as I said, I'm going to share this script with you on the video description. Feel free to learn from it and change the parameters. Thank you so much for your attention. I'll see you in the next video.